Introduction to Fluids. At the end of this lesson, you will be able to explain about fluids, describe the concept of continuum in fluids. How do you get the breeze when you switch on the fan? How does the water stream down when you open the faucet? How does the gas stove give you a burning flame? What makes the blades of the windmill to rotate? What causes turbines to generate electricity? What makes you feel cool when you switch on the AC? All these above-mentioned actions commence due to the flow of different types of matter. It's a known fact that everything around us is made up of solid, liquid, and gases. However, the majority of the Earth's portion is covered by liquid and gases, which are grouped as fluids. Fluids are the type of matter that are capable of flowing. In other words, it is the matter which deforms under loading. The study about the behavior of fluids is known as fluid mechanics. Fluid mechanics deals with the study of static, kinematic, and dynamic aspects of fluids. Statics is a study of fluid at rest. Kinematics is a study of fluid at motion without considering pressure forces, and dynamics is a study of fluid at motion considering pressure forces. In this topic, you're going to learn about fluids and concept of continuum in fluids. We are already well aware that fluids are available in three forms such as liquid, gas, and vapor. The liquid is any form of fluid which possesses a specific volume. Under compression, fluid stores energy similar to solids. However, it is ignored as the contraction of the volume of a liquid is extremely small. Thus, liquids are incompressible. The molecular attraction between the particles causes a fluid to withstand a slight amount of tension. This causes a shear resistance between the two adjacent layers. This is termed as viscosity. The other form of liquid is gas, airflow, which makes you feel chilled when you switch on the AC, is the liquid in the form of gas. Gases do not possess a definite volume, but they are compressible. In some cases, the gas that has a temperature and pressure nearer to the liquid is called as vapor. Based on the state of flow, the fluids are classified as ideal fluids or real fluids. Ideal fluids are those which have no viscosity, no surface tension, and are incompressible. In general, an ideal fluid does not exist in nature. However, the fluids with a low viscosity and air are considered as ideal fluids for theoretical analysis of the fluid motion. These considerations play a supportive role in simplifying the mathematical analysis. The fluids which have viscosity, surface tension, compressibility, and density are called as real fluids. Thus, we can say that all fluids available in nature are real fluids. In general, continuum fluids are the ones available in nature. These types of liquid, when viewed at microscopic levels, show different intermolecular distances called as mean free path, denoted as lambda. The mean free path of a gas is comparatively less than the other physical forms. Thus, under such considerations, the liquid is discontinuous. Whereas, in the macroscopic observation, the flow variables such as pressure, velocity, etc. are taken to be continuous. Its properties vary continuously from one point to the other. This state is said to be a continuum. Thus, the concept of a continuum is an idealization of the continuous picture of the fluid, where its properties are considered as a continuous function of space and time. The continuum of fluid is described by considering mean free path and characteristics length. The characteristics length is the length or breadth or height of the medium based on the fluid flow. It is dimensionless parameter and are denoted by Kn, which is equal to lambda divided by L. Usually, if Kn is greater than 0.01, the continuum in the field is not good. If Kn is less than 0.01, the continuum in the fluid is good. The concept of continuum is found to be satisfactory for both liquids and gaseous form except for gases at very low pressures or at very high temperatures. In mathematical relation, the fluid flow is considered as reliable and fluid medium is treated as a continuum. For instance, density at some point of flow is expressed as rho is equal to limit delta for all to 0m divided by delta for all. Delta for all is the volume of the fluid element. M is equal to mass of the fluid. If the volume of the fluid is very large, the density of the fluid is affected by inhomogeneities in the medium. In case, if the volume of the fluid is very small, there are possibilities of random movement of water. Thus, to make the fluctuations to be significant, the density of the fluid medium is considered within continuum limits and is denoted by delta for all C. Rho is equal to limit delta for all to delta for all Cm divided by delta for all. Thus, in continuum approach, fluid properties such as viscosity, surface tension, compressibility, density, etc. are expressed in continuous function of space and time. Let's sum up. Fluids are the type of matter that are capable of flowing, which includes liquid, gas, and vapor. Based on the state of flow, the fluids are classified as ideal fluids or real fluids. The concept of continuum is an idealization of the continuous picture of the fluid, where its properties are considered as a continuous function of space and time.